Hey guys, today is Thursday, May 14th, 2020, and welcome to a 3-part series on stars. So let's talk about what we're going to be doing today. So today we have kind of 2 things. After you watch this presentation, then you're going to watch a little video clip on how we study stars, and you're going to be completing an activity where you're focusing on our star, which is the sun. So let's get into the presentation for today, and we'll talk about what we're doing today and over the next couple of days as we explore stars. Okay, so you guys know we kind of started out here with our unit trying to determine what is this kind of perfect concoction to allow life to form, and is Earth unique, or are there a lot of other Earth planets out there? So first thing we know, we have to be in the right neighborhood, which means in part that we need to be in the habitable zone around a star, which you guys learned about yesterday. But it has to be around the right type of star. There are a lot of different stars out there, and we've kind of narrowed it down to one particular type that seems to be more productive, we'll say, in the formation of life. And of course, our star, the sun, falls into that category. So we're going to explore that today. The first thing you guys need to know is a little bit about how we study stars and how we study space in general. Since we can't travel very far yet in outer space, and even if we could not land on a star, we could not touch a star because it's so incredibly hot that we have to use other types of data, and that comes from what we call radiation. Okay, and radiation is basically the energy that's emitted from the star. It's put on a scale called the electromagnetic spectrum, and you guys actually have learned about this before when we talked about UV radiation in meteorology. Okay, so this is the electromagnetic spectrum. You can see ultraviolet light over here, but basically it's taking energy and it's categorizing it by how long or short the wavelength is. Longest being radio waves, shortest being gamma rays. You can see visible light, which is what we can see, what our eyes are sensitive to, is smack in the middle, hence the little rainbow down here. So feel free to explore this a little bit more on your own if you'd like to, but just so you know that that's what we use to study stars. Now, the way that we actually study the radiation is through 2 tools. Okay, the first tool, of course, is a telescope. Okay, that's pretty much a given. The things that you guys need to know about telescopes is we kind of place them in 2 spots. Either they're at high elevations on Earth's surface, or they're in outer space. It's preferable to have ones that are orbiting the Earth as opposed to being on the ground, because it doesn't have the interference of the atmosphere, which filters out the radiation. You get clouds and water vapor, and it causes all kinds of trouble. So much better to have telescopes that are orbiting around the Earth. In this slide, you guys can look at this more on your own. We have different types of telescopes, so if this is something that's interesting to you, you can check it out. These are some of the famous telescopes that are in orbit. Currently, there will be another one going up in the not too terribly distant future, although I feel like every time I look at the date gets pushed back, which is the James Webb Telescope. Okay. The other thing that we use to study stars besides the telescope that we really look at to analyze that radiation is something called a spectroscope, which gives us the star's spectrum, okay, which is in this bottom corner. Is you can see it's basically a little rainbow. It's actually a fingerprint. It's like a fingerprint for a star. The radiation passes through the spectroscope, which is a prism, and it divides the light into this little mini rainbow, or basically it's dividing it up by its wavelength, and we look at this spectra and analyze it. So like some stars, for example, you can see this has like a small section of red. Some stars might have a really big section of red, and maybe a teeny tiny section of purple, or maybe like a huge section of green compared to this one. They're all going to be a little bit different. It really just excuse me, depends on the star itself. And by studying this, we can learn a couple of things. We can learn the temperature of the star, we can learn its composition, and we can also learn how it's moving. Is it moving towards us or is it moving away from us? Now, there are 3 different types of spectra, which I've outlined here. I'm not going to go over all the details about it because you guys, unless you're really interested in this, I'm not too worried if you don't know exactly all the 3 types. What I actually did, which is probably easier than reading all of this, is I put a little very, very short clip that kind of simplifies how spectra is created and how it works in Google Classroom. I highly recommend that you guys check that out. It really simplifies this whole thing. Okay, but nuts and bolts of this, the way that we study stars, since we can't travel to them, and even if we could, we can't sample them or take their temperature or anything, is we study their radiation using a spectroscope and using a telescope. That's sort of what you really need to know from those slides. Okay, so what we need to kind of focus on are the types of stars that are out there. Obviously, the sun, our star, is the right type of star. The sun is just the name of our star. There aren't other suns, so to speak, out there. The sun, you can see here, is called a main sequence star. That's its classification. There are a lot of main sequence stars. Our star is yellow because it's kind of an average temperature. It's mostly hydrogen and helium. It actually has the same density as the gas planets like Jupiter and Saturn because they're also made of gas. And you can see it's about 109 Earths. If you line them up all end to end, would equal the same diameter as the sun. Okay, so when we're classifying stars like the sun, one of the things that we use to classify them is temperature. Okay, the sun is in the middle for the temperature range. It's a yellow star. If it's more towards the blue side of the temperature range, it is on the hotter end. If it's more of a red star, then it's on the cooler side. Okay, the composition, which again we get from the spectra, we know most stars are made of hydrogen, helium, and then little bits of other elements. But what we're really looking for is how much hydrogen is it made of, how much helium is it made of, how much of the other elements, and that also gives us information about its age. Our star is about 5 billion years old. It is halfway through its life cycle. So in another 5 billion years, that's when our star will begin to die, which is what we're going to discuss actually on Monday. Okay, so again, the way that we study this, we can't collect a sample of the sun, so we use the spectra to figure out what it's made of. Okay. The other thing we look at is brightness, and there's a couple of different scales that we can use to describe or measure a star's brightness. What we typically use is this one, though, called absolute magnitude. It's the most accurate. It's, I would say, the most up-to-date one out of the 3. But the scale, just so you guys know, is backwards. Okay, the lower the number, the brighter the star. So like in this little scenario here, star B would be the brightest star out of these 3 because it's a -2. So you're always looking for, when you're checking out the brightness of a star, the lower the number, the brighter the star. Okay, so once we've gathered this information about composition, temperature, brightness, we plop it onto a graph just like any good scientist would, and we follow the pattern, okay? And that's actually what scientists Hertzsprung and Russell did. They collected thousands and thousands of sets of data on stars, and they plotted them, and they noticed that they tend to kind of cluster together. And they realized the reason why they cluster together on the graph is because they're the same type of star. So these are the guys that created this star classification system. So down in the bottom corner, we have white dwarfs. In the top corner, we have supergiants, and we have giants just below that, and then extending diagonally across the graph is main sequence. We are going to talk more about the different types of stars, these 4 classification groups, tomorrow. Okay, so more to come on this later. For right now, I just wanted you to see just some background information. All right, going in the wrong direction here. So what you guys really need to know and focus again on today is the sun. So we are the main sequence, okay? Most stars are on the main sequence right now. And just to give you guys a size comparison, main sequence stars are small. Even though it's huge compared to us, it's not very big compared to other stars in the solar system or in the galaxy. Excuse me. So the sun is less than a pixel in this particular image. I found this actually on Reddit the other day. And then Betelgeuse, which is a supergiant, if you remember that spot on the graph, its diameter is larger than Jupiter's orbit around the sun, okay, which is like incredible, okay? So just to give you guys a little scale as to, excuse me, the size comparison of some of these. But again, more to come on this tomorrow. A lot more to come on this tomorrow, okay? So what I want you guys to focus on today is just learning more about our star, the sun. So you're going to follow this interactive website. It's pretty awesome. I like it. And then you're going to follow up with the Google document in Google Classroom, answer those couple of questions. Look back at these note slides. I don't want you guys to feel like you have to memorize all this stuff. I know it was a lot of information. What you really need to take away is the way that we study stars is through radiation, and that's measured with telescopes and spectroscopes. And then we classify stars based on like their temperature and their composition, and that's how we decide that the sun is main sequence, which is of course the right type of star. So just skim through this. Don't feel the pressure that you need to like memorize all this stuff today. Just kind of get an intro. You really just want to focus on the characteristics of our own star. All right, guys. Remember, if you have questions, stop in office hours, hit me up through an email or through Google Classroom. I'll be happy to help you guys out. And I hope you have a great day. I'll see you all tomorrow, which is Friday.